My name's Matthew Aslett. I'm Research Manager for Data Management and Analytics at 451 Research. I'm going to be talking about the role that we see that NoSQL and graph technologies play in the total data management landscape. So specifically talking about big data, total data, NoSQL and graph, although not necessarily in that order. Before I get into that, just wanted to introduce obviously myself and 451 Research, aware that perhaps not everybody here knows the company and the background of the company. So 451 Research is an industry analyst firm focused specifically on IT innovation in the software, hardware, services, systems, and the whole IT industry. We have expanded over the years with a couple of acquisitions as well. Added Tier 1 Research, which is focused on the cloud and hosting market. We've also added the Info Pro, which focuses specifically on kind of end user engagement and end user related research. And also ChangeWave Research, which is focused more on analyzing spending behavior and spending patterns, both at a consumer and a corporate level in terms of technology adoption. So all of those companies, plus the original 451 group, now make up 451 Research. 451 Group becomes the parent company and also owns Uptime Institute, which is another of our acquisitions, which focuses specifically on the data center industry and has its own events, professional services team, and networking. So that's the two main organizations that make up the 451 group. 451 Research has about 55 analysts spread throughout the world. We've got an office here in San Francisco over on Geary, headquartered in New York, and quite a big presence in the UK as well. Actually, most of the founders of the company came from the UK, so we've got a large presence there, and I'm based over there in the UK, and as is typical on trips over to this side of the pond, I've been awake for hours, so please bear with me as we go through the presentation. So I am Research Manager, Data Management and Analytics, as I say, been with the company since 2007, and I've had two main areas of interest at the 451. I'm part of the Information Management Group, specifically focused on data management, which traditionally has meant operational databases, data warehousing, data caching, event processing, and then obviously more recently, things like Hadoop and the expanding data management landscape, which obviously I'll talk about. I'm also part of our commercial adoption of open source practice, which, as the name suggests, is focused on the commercial adoption of open source, both in terms of the adoption of open source projects by end user organizations, but also the adoption of open source licensing and development methodologies by traditional incumbent vendors. And that dual role has been pretty useful, I think, in recent years, and we've been looking at the expanding big data technologies. If not all, but the vast majority of those are open source and actually came onto our agenda first through the commercial adoption of open source practice. So looking at, initially at Hadoop as an interesting open source project that was obviously getting a lot of interest, and then we picked that up in the information management practice as we see vendors forming around that project. Similarly with NoSQL, initially started looking at interesting data management projects, and I actually realized the other day we started writing about NoSQL technologies before they were called NoSQL technologies, which goes to show perhaps that we're a little bit ahead of some of the other analyst vendors in terms of looking at innovative organizations, innovative projects, innovative companies. If it's a company, it's a two-man shop, but they've got something interesting, we'll follow it. We don't have to wait until it gets on to a larger enterprise radar before we'll pick up a technology and start analyzing it. So that's who we are, and the sort of research we produce daily research for our subscribers, but also produce kind of these, what we call long format reports, digging into a specific technology area and looking at the trends and things like market sizing and surveys in those reports. So these are just some of the few we've published over the last kind of 18 months or so. As you see, in April 2011, we published our first report looking at the NoSQL space, also the NewSQL databases, so sort of the new breed of relational database technologies, and for better or worse, we coined the phrase NewSQL for that, and it seems to have taken off a bit. And we were looking there at what are the drivers for these technologies? Why have they come about? Why have they been developed? Why are they being adopted by enterprises? We followed that up more recently in May this year with a report looking at MySQL versus NoSQL and NewSQL, looking more specifically about the competitive dynamics in the space. How are people adopting these technologies? How do they compare? That included some market sizing figures and some survey data, and I'll include some of that as we go along. In the middle, as you can see, in December last year, we published our total data report, which is our perspective on big data, and again, what the drivers are, what the trends are. And I'll explain what we mean by total data in more detail, but it's essentially, it's not a replacement for big data, it's about how you actually generate value from those big data projects, how you actually manage some of those big data technologies. And we're actually in the process right now of finishing off the follow-up to that report, which is focused specifically on the implications of big data in the analytics sector specifically. So that will be called, I think, Total Data Analytics, and will be out as soon as we've finished it, which hopefully will be later this year. So I'm going to start with NoSQL, because I think in some ways that was our starting point for looking at some of the technologies in this space. And as I say, we published that report, and we were specifically looking at why these technologies come about and why they're being adopted. First, of course, we have to define what we mean by NoSQL, and this is something of a movable feast. It's changing all the time, obviously, as some of these products develop. But what we defined it as at the time was the new breed of non-relational database technologies. There's a lot of technologies here, and we'll go into more detail on that, but I think what we saw they had in common was the rejection of fixed table schema and join operations, and or schemaless data management requirements for more flexibility and agility. Many, although not all of them, are designed to meet the scalability requirements of distributed architectures as well. So those are some of the kind of the common characteristics that we looked at. Obviously, there's a huge number of projects in this space. This is an incomplete graphic, but it just goes to show where some of these technologies are and where we see them fitting together in terms of key value stores, overlapping with, well, we use the term big tables for, people use the term wide column store, etc. But we think that has the potential for confusion with, column-oriented analytic databases. So we use big tables for that. Obviously, document database technologies and an element of overlap there with key value stores. And obviously graph as well. And as you'll see, and we'll go into more detail on this, we see graph as being a slightly separate category, part of the whole overall NoSQL ecosystem, but a slightly separate category and used for slightly different use cases. There's various ways of looking at the growth of NoSQL and what's happening with the adoption of NoSQL. One of the ways we've been looking at this is actually doing a search of LinkedIn and looking at the number of times these projects are mentioned in the profiles of LinkedIn members. You have to, in order to do this, you have to slightly figure out how to use LinkedIn search, and there's some interesting quirks about that which I could go into, but if we want to discuss that offline. But obviously we had to do some clever things to search for Cassandra, but not search for people called Cassandra, and there's various other things, especially when you have like Couchbase and Membase. But this is the latest rev of this. As you can see, we see the greatest adoption for MongoDB, which I'm sure will not come as a surprise for anybody who's already interested in NoSQL databases. Also a lot for Redis and Cassandra, and Neo4j down there. Definitely the primary graph database from at least this perspective, and others as well. Down there in I think it's about 7th place. But again, you see a significant level of interest and the range of the technologies involved. We also looked in the most recent report at revenue figures and projected revenue figures for NoSQL. Starting off in 2011, where we saw there was 20 million in revenue for NoSQL databases, which is a small number, but it's very early stages, and also the caveat to that is that we're looking specifically at licensing and support subscription revenue. So we're not looking at the applications, the hardware, the kind of systems integration services around that, but specifically licensing and subscription support revenue. But we see that growing pretty rapidly, 82% compound annual growth rate to 215, I think, million in 2015. So why do we think there is this interest? Why are we projecting this level of growth? The answer to that comes down to sprained relational databases, as is graphically represented here. So a sprain is an injury to the tendons caused them being stretched beyond their normal capacity, almost but not quite the breaking point. And we think this is actually a pretty good analogy for what we see happening in the database space. You know, the relational database has been the primary database of choice for enterprises for the last 30, 40 years. But what's happened over that time frame is that more and more capabilities have been added to the relational database that it was never designed initially to support. So things like object-oriented support, XML support. Also in terms of scalability, the move to more distributed architectures, there are workarounds for distributing relational databases, but they were never truly designed to operate on those sorts of architectures. So what we've seen is that the operational database is being stretched almost to breaking point. If not the operational database, and I mentioned there are workarounds for this, but we also see is that workarounds like sharding and cluster management, etc., can do the job, but they're very complex, and we see that actually it may be the database administrator that's being stretched to breaking point in order to deal with all that complexity. And put those two together, what we've seen is now more so than ever before, I think organizations, enterprises are prepared to look at the alternatives to the relational database, where it makes sense to do so. Obviously, there are still a huge number of applications where the relational database is the best fit, but if it's not the best fit, they're much more prepared to look around at the alternatives, the emerging technologies, than they were previously. SPRAIN also is an acronym, and it stands for the 6 key reasons that we see that are driving this change amongst end-user organizations, and this willingness to look at the alternatives. So those are scalability. As I said, most but not all NoSQL databases are designed to be inherently scalable. Performance is highly related, but important, I think, to call it out separately. Performance, often the issue is performance at scale, but sometimes it's just a matter of performance. And Emil talked this morning about people adopting things like Neo4j for that performance of applications that are suitable to that environment. Relaxed consistency, cap theorem is also important here, obviously more specifically for NoSQL databases than NewSQL databases. Agility is another core aspect here. We see a lot of this driven by developers, and it's about a more agile development process. And again, Emil talked about kind of the whiteboard friendliness of Neo4j, and we see that definitely being a core aspect, not just for graph databases, but also document databases, key value stores, and developers not having to get bogged down in the schema for their database as they develop their application. Intricacy is another aspect here. What we mean by that is we're talking about different data formats, unstructured and structured data, more complexity. Obviously, again, this is clearly where graph databases come into play in terms of dealing with the complexity of relationships between data entities. And lastly, we look at necessity. One of the key aspects that really jumped out from our research in this space is that a lot of these technologies were developed by organizations because it was necessary to do so. And this is a great quote, I think, from Werner Vogels, the Amazon CTO, that really demonstrates this, that as he says here, we couldn't bet the company on other companies building the answer for us. So as Amazon continued its process to move to more distributed architectures, and it needed a data management layer to support that, it looked around at the vendors that were out there and realized that they weren't going to supply it with what it needed. So it had to develop its own data management technologies. Also, as you can see, I hope maybe not from the timeline here, also we see Google as being a significant player in this space. Some interesting open source projects, obviously particularly Nutch, and some of that research from Google coming together with that those open source projects to eventually produce Hadoop. And then companies like Yahoo and and Facebook and others picking up on that research and developing their own implementations of that, again, because they felt they needed to, because the existing data management players weren't going to supply them with the technologies they needed. From that, we've now seen this ecosystem of new vendors emerge that mean that hopefully the next generation of Facebooks and Amazons, et cetera, won't have to develop it themselves. Obviously, it's, that's not the ideal scenario when you have companies that aren't, aren't necessarily technology vendors developing those technologies themselves. But, as the research continues, and we see, a whole new breed of research coming out of Google into things like Dremel and Percolator and Spanner, which are, again, inspiring the next generation of data management technology. So this, this process continues despite the fact of the emergence of this vendor ecosystem. And I think they'll continue, obviously, to feed off each other. And it's actually, I think, it's been hugely good for innovation in the data management space that this process has occurred. So again, just to reinforce, the importance of necessity here, if you look at some of these key data management projects and where they came from, companies like Google and Amazon and Facebook, not what we would consider, obviously, you could argue they're technology vendors, but not what we would consider traditional data management technology suppliers. And also in here, we have Neo4j. I'm not sure if many people are aware that Neo4j initially came about within an end user organized, what we would define an end user organization. So Win Technologies, a content management and a media firm. And also, as you can see here with Apache Accumulo, it's not just web companies that are getting in on this process, but also, the US government as well. So the important point also to make, as I said, there's a wide variety of technologies in this space, a wide variety of products. And those 6 aspects, scalability, performance, relaxed consistency, etc., don't necessarily apply to all of the products in that space. And this is just to pick out a few examples, MongoDB, Cassandra, React, and Neo4j, to show how they are dealt with by different technologies in different ways. Just to highlight that, scalability, as I say, is often considered, kind of hand in hand with NoSQL. But if you look at MongoDB, it still has that kind of master-slave architecture that MySQL has. And so, depending on your use case, may not actually be the right scalability solution for you. Obviously, it has other benefits. Neo4j as well, due to the graph data model, you can see that it's not inherently as scalable as things like Cassandra or React, but it makes up for that in other ways. And the other point to highlight here is, relaxed consistency is another thing I think people immediately associate with NoSQL. It's not necessarily the case. Neo4j actually, does support ACID transactions, and so, doesn't fit in the relaxed consistency category. That's not a bad thing. It's just the nature of the technology involved. And, we see this move towards, what's been termed kind of polyglot persistence and much more interest in using the right technology for the right kind of workload and application. And something like this probably helps people to think about different technologies and how they fit. Obviously, this is a graph event, and I'm aware that this is a table, so I redrew it in a more graphic fashion. I'm not sure this actually helps. Probably I should have been in the tutorials yesterday, but anyway, it's a different way of looking at the market and the relationships between kind of the Sprain aspects and the different technologies that are available. So to zero in on graphs specifically. So I mentioned that we saw there being 20 million in revenue from NoSQL databases in 2011. Graph actually makes up about 4% of that, but growing to 215 million in 2015. Graph we think will represent 8% of that. So that the whole pie is growing, but also Graph's share of that pie is growing as well. The caveat to that is that due to the way in which we calculate our revenue projections, there's likely to be an extremely conservative estimate. 451 Research market sizing estimates are always extremely conservative. And the reason for that is when we're looking at a market, we go and take each vendor in turn and we look at what is their revenue today, what is their kind of justifiable growth projections, and we also apply obviously our own perspective on that. And so what that means is for the figure for 2011, we can be absolutely sure that that's a really defensible number. What that means, though, in terms of the growth, is that obviously as new players emerge, the growth is going to expand. I think, other organizations might sort of think, well, Oracle might enter this space, so let's add on another however many million. That's not something we do. We'd rather go back after the event as new players emerge and push our numbers upwards, if that's the case. And I think it's definitely going to be the case in the NoSQL market. We saw, at the point at which we put these numbers together, some players were still emerging, still at the proof of concept stage, and so very low in terms of revenue at that point. We've also, particularly in the graph space, as I'll explain, we've seen a real explosion in the number of players in that space. So there is going to be revenue that's generated in forthcoming years that isn't included in this analysis, but we're going to revisit these numbers in early 2013 and then onwards from there. And as I say, if they need pushing up, we'll definitely push them up, and we have no problem about doing that, as long as we're starting from the correct number, which we believe we are. So I talked earlier about our kind of LinkedIn analysis and where we see Neo4j fitting in there. What this representation doesn't show is the growth over time of the LinkedIn members citing some of these projects. And what's interesting is if we break that out by a selection of the highest growth. This is from December 2011 to September 2012. What we see is Neo4j is the fastest growing of the NoSQL projects that we looked at in that space, actually growing nearly 300%, obviously from a much lower starting point than MongoDB, which is growing towards 250%. But still, really significant growth, and I think speaks volumes about what we're seeing about a greater understanding of the role of graphs as specific to the interest in NoSQL as a movement itself. The particular drivers for graph, and obviously Emil talked about some of this earlier, but just from our perspective, as I say, graph databases may lack somewhat in scalability compared to the others, but I think what they more than make up for is the ability to deal with complexity and obviously, as I mentioned, transactional integrity. Graphs specifically handle relationships that are too intricate to be represented in the relational model without complex joins. And also, the support for semi-structured and unstructured data, which don't fit into a rigidly enforced schema. So that agility aspect as well.
Excuse me, question.
Yeah.
Could you elaborate just briefly on why you say graphs don't scale as well? You mentioned the graph model, but could you just give a few more sentences on that?
Yeah, so obviously if you have the graph data stored in a single database and you're running your queries, the query is defined to that single database. As soon as you start sharding the data, it obviously becomes more, or you have multiple servers, it becomes more complex to run queries across that, across those different servers. And so, that then is specific to the graph model, where you do obviously, depending on the query, but you probably do want to run your query against all of your data. And so, it's not necessarily as efficient at doing that. Obviously, I know Neo4j and some of the other graph database vendors are working very fast to get over some of those issues. So it's inherent to the nature of the graph model and the fact that you want to be looking at both the entities and the relationships between them. And obviously, in a relational database, if you apply your schema ahead of time, you know what those relationships are, but that then restricts the queries you can ask. Obviously, in a graph database, you don't want to do that because you don't know what the relationships are, and the whole point is to analyze those. So you don't want to restrict the queries that you're submitting.
Right.
Yeah.
So I think your argument is predicated on that you be sharding the graph database. But is that necessary with a graph database like it would be with relational? Is it as necessary, given that the footprint of the graph can be larger?
I mean, it definitely depends on the nature of your graph model, the volume of data we're talking about. So as with all things, it really depends on your specific application whether you would even require that in the first place. So there is that caveat, but just talking about the graph model itself requiring that kind of analysis doesn't necessarily lend itself to kind of sharded distributed environments. Thanks. What the graph model does lend itself to, nice link there, is obviously social networking and geolocational data. But as Emil demonstrated earlier, we do see this in more enterprise class applications, specifically things like master data management and kind of network management, and anything that kind of neatly fits on a visual representation. And again, back to that kind of whiteboard friendliness. So if we look at the the players in this space and how we look at how they fit, and this is perhaps imperfect, but it's our view of how the different players fit and where they've emerged from. We see players like AllegroGraph from Franz Inc. and HyperGraphDB used more typically for kind of RDF and semantic web kind of applications. Those with our focus not being the kind of technologies that we look at specifically. We're more interested obviously in the enterprise implications of these technologies, and so we look more at the likes of Neo4j and DEX from Sparsity and OrientDB, which are much more applicable to kind of more commercial enterprise use cases. And what we've seen is an expansion of players in this space, obviously Nuvula based on OrientDB, but also a number of the existing relational database technology vendors getting into this space and other players getting into this space. So Microsoft has some research projects that are underway. Not clear quite how what impact they'll have, or indeed whether they'll make it to market. But it's interesting that Microsoft sees an opportunity for research here, and that there is a need perhaps for graph database technologies alongside things like SQL Server. IBM has actually introduced graph processing into DB2 with its latest release earlier this year. They've gone a little bit quiet about that since, but it's certainly something that they see a need for to address, obviously in DB2. Other players, obviously Oracle's an interesting one. They renamed Oracle Spatial a few months ago, Oracle Spatial and Graph, to highlight the fact that it has graph applicability. So again, really I think highlighting the fact that we see a growing interest in graph specifically rather than NoSQL more generally. And when a company like Oracle begins to respond to that, I think you can see that a tipping point perhaps has been met, at least in terms of the the noise and the interest level. Other players entering the space: Yark Data, obviously from Cray, and then Affinity, a project coming out of VMware, again early stages for that. And then more on the open source side, so Twitter released the FlockDB project that it runs internally, and also then Apache Giraffe, which is a project that runs on top of Hadoop. And we expect this expansion to continue, as I say, given the ongoing interest levels in graphs and the potential opportunities there are obviously for new applications based on graph technologies. So another way to look at this is in terms of the core functionality and the core capabilities. Obviously, when we talk about things like Microsoft and Oracle and DBT, and I forgot to mention Infinite Graph from Objectivity, bringing out graph technologies, what we primarily see those as is graph compute engines which sit on top of a back-end database that isn't necessarily a graph database itself. It's not necessarily taking advantage of graph storage, versus technologies like obviously Neo4j and others, which are true graph storage and graph processing. So I think it's just an important way to start thinking about the different technologies in this space and how applicable they might be to a certain project, and just one way of looking at it. Obviously, to say it's not perfect, there's various different ways, and you can get quite down into the weeds, because I mentioned earlier, the RDF semantic use cases actually, say for example, IBM is making use of semantic graph technologies within DB2, but it's obviously aiming those at commercial enterprise use cases. So different ways of looking at it, but that's the perspective we look at in terms of dividing up the market as it stands right now. So I wanted also to talk about big data, because I think you can't really ignore that when you're looking at the growth of NoSQL and graph databases as well, and what the drivers are. Obviously, big data, a big trend, and is shaping the market going forward. The way we look at that is that big data describes the realization of greater business intelligence. specifically by storing, processing, analyzing data that was previously ignored because due to the limitations of traditional data management technologies to handle specifically its volume, so the volume of data being too large for traditional database software tools to cope with. Velocity, the data being produced at a rate that's beyond the performance limitations of traditional systems. And variety, so the data lacking the structure to make it suitable for storage and analysis in traditional databases and data warehousing. And I think probably by now everyone's come across the 3 V's definition, and there's many other V's depending on how far you want to take this, but we stop there in terms of that being the core drivers for some of the underlying data requirements. But we think there's more going on here than just the data itself. There's also a trend that's shaping the adoption of these technologies driven by what users want to do with that data. So we see the increased use of interactive applications and data generating machines is driving this volume, variety, velocity of data, and it is a core challenge for companies to deal with. But also we see that companies see a commercial opportunity in taking advantage of that data that they previously threw away. So because of that, there is this increased desire to store and process all available data, or at least as much as is economically feasible. And the good thing about technology like Hadoop and NoSQL databases and things like cloud storage is that it now is more economically feasible to store and process all that data that was thrown away. That obviously requires new infrastructure investments to support that data processing software, and that's happening in the cloud as represented here, but also in terms of on-premise infrastructure as well. And the interesting thing is, obviously, the more infrastructure you have, the more machines you have, the more data those machines are producing, and the more opportunities there are to analyze the data being produced by those machines. So it effectively becomes kind of a circle that's driving itself. So that's one of the reasons why we think big data is going to have a serious impact on the industry moving forward. As I said, though, we think it's not just about the data; it's what end users want to do with their data, and that's what our total data concept is all about. It's not just a matter of removing the word big and replacing it with total. The way we think about this is, if your data is big, the way you manage it should be total, and the way you engage with it should be total. And we look at 4 aspects to that. So the first is totality, and we see an increasing desire amongst organizations to store and process all available data and analyze all available data as much as is economically feasible, rather than taking a sample of data and analyzing that and extrapolating the results, which is obviously a common workaround for some of the limitations that we talked about earlier with existing data management technologies. We also see exploration as driving interest here. So we're talking here about more what we call exploratory analytic approaches. So essentially, defining the schema in response to the query, rather than limiting your potential analysis by defining the schema when you store the data. And I think a lot of that is actually driving interest in the space. Both obviously Hadoop is a key example of that, but we also see it in the NoSQL space, particularly with graph databases and document databases, as giving that flexibility to the developers to focus on developing the application and worry about perhaps how that's going to be analyzed at a later date. Frequency is another important aspect. We talk about velocity being the rate at which the company is producing data, or the rate at which data is coming into an organization. Frequency is kind of the flip side of that, and it's more about the rate at which organizations want to query their data and analyze their data. And we see a lot of companies moving to more frequent analysis of their data to get a better, ideally more accurate prediction of where they are, how they can serve their customers, and how perhaps how their infrastructure is able to cope with their business requirements. And the last is dependency. So it's important, obviously, huge amount of interest we see in NoSQL and Hadoop technologies and other new data processing technologies, and also things like MapReduce as well, in terms of ways to analyze your data. But there is this huge existing reliance on on relational database technologies and SQL tools and skills, and particularly skills is the key aspect here. I think probably everyone's heard about the shortage of kind of data scientists and skilled people to engage with things like Hadoop and NoSQL databases. And so obviously we see a trend towards making SQL technologies work more efficiently against things like Hadoop. SQL-like programming and analysis being brought to NoSQL databases as well. And so there is the need for end-user organizations to balance that interest in the new with the existing investment in the old. So, putting all this together, where do we see NoSQL and Graph specifically, fitting in that total data landscape and amongst those total data drivers? This is as a graphic that's taken from this forthcoming report that we're producing, as I said, targeted specifically at the impact kind of on the analytics space. And it is obviously a vast simplification, but this kind of represents the traditional approach to analyzing data within an organization. You have your applications producing structured data into the operational database. You can do predefined reporting on that, but obviously you'd also pass that data into the data warehouse for more kind of ad hoc analysis and predefined reporting. So as the data management landscape has evolved, so have the opportunities for analytics. And so we see an increased interest in statistical analysis, predictive analysis, machine learning, MapReduce, and beyond, but they're obviously the evolution of Hadoop beyond MapReduce, with new frameworks being made available on that. Obviously Hadoop as a new data source, particularly for semi and unstructured data. Also, we see NoSQL playing a role here for new applications and enabling an opportunity for what we've described as operational intelligence. So more, real time, you can get bogged down in definitions of real time, but so operational intelligence, more a view on how the business is doing right now rather than how it did yesterday or how it did last week. And also potentially we see, in-memory database technologies and stream processing technologies playing a role there. So where does Graph fit into this? As I said earlier, we see Graph, the drivers for Graph and the adoption for Graph being quite different from some of the other NoSQL database technologies. And we see two distinct Graph roles. Being used for relationship-driven operational applications. And I talked earlier about the ACID transactional properties, specifically of Neo4j. And so we're not just talking, even though the focus in this graphic is on the kind of the analytics potential. We also see that driving transactional operational applications, but also obviously the analysis of relationships, as we heard in the keynote this morning. The reasons for that, there are distinct benefits to Graph technologies. Obviously there's native support for storing and analyzing the relationships between data. Also, high performance versus the relational model for processing, not just the data, but the relationships again between data. Support for semi and unstructured data, as long as alongside more traditional kind of structured data analysis. And also the flexibility to support continually updated data sets. Again, back to the kind of the agility angle here about developing applications that may change over time. And that's something that the relational model and kind of the schema on write approach is particularly bad at, is enabling that flexibility to respond to change as the business requirements change and the applications change. Obviously, as you get not least new users, new ways of wanting to analyze that data. And that speaks to kind of iterative development as well, being able to develop those applications with that freedom and that flexibility. So we see Graph databases as fitting as a separate category, kind of alongside some of the other opportunities for analytics here, as well as the operational applications, as I say. So applications feeding data directly into Graph databases, also data coming from existing data sources, data warehouses and Hadoop, into Graph to give you a new perspective on that data which you already own and already have, and giving you new opportunities for generating value from that data. And so that is the role that we see NoSQL and Graph databases specifically playing in the total data landscape. So that's the presentation. I'm more than happy to take any questions if there are any coming from the floor. Yep.
Your last slide, stovepipe use of graph applications very narrowly. A larger IT landscape where graph, we consider graph as enhancing some of the other use cases that are in medical operation, as opposed to just being essentially a stovepipe.
Yeah, I think it's more to do with the actual the imagery. I mean, certainly we don't see that. I mean, as I say, we see it being able to feed data from existing sources and enable new opportunities based on that existing data. I think, it is something that we see, that it is going to be deployed for obviously specific specialist applications, definitely at this point. And so by that nature, it is going to be, considered separate from some of the other use cases. But I see that, I mean, my perspective on that is that, for the graph database technology, that's a good thing, that it has its own space rather than the potential to be kind of, more, absorbed into kind of the relational database technologies. I think, even though we've seen, say, for example, IBM doing that, I think the specific benefits of graph databases will drive that as a space in and of itself. But as I say, as part of a wider ecosystem. So yeah, don't get me wrong in terms of it just sits completely separately as a niche. I think it definitely fits within that wider ecosystem, enabling wider analytic opportunities.
Well, building on that, what would it take to make graph more amenable to be incorporated in the there's standards like in education, they're part of that people as well. So they're everywhere.
Yeah.
There, and whether it's standards are supported or whether, I was curious what you observe perhaps over time and graphs.
Yeah, I think, well, for a start, it's just familiarity. I think, one of the questions, we ask ourselves when looking at this is, as an end user, how do you know you have a graphable problem if you're not already aware of graph database technologies? And so there's that aspect. But I think, as I say, we see that definitely changing. We see growth in the understanding of graph and the implications of graph growing all the time. I think, there is, the matter of connectors into the existing data sources. We've seen that, a huge amount of interest in that in kind of Hadoop, and that now becomes part of that ecosystem. I think we'll see that with graphs as people begin to realize the potential and the opportunity and the need to connect some of those data sources more. I think standards is potentially an issue. I think we do see some work going on in terms of standards, certainly in terms of query interfaces, and the other issue as well is obviously with more kind of SQL-like analysis of graph databases being enabled. That increases the familiarity to perhaps bring it into an end user audience that already has, as I said, that the kind of dependency or significant investment in kind of the SQL skills base. So I think there's a number of aspects, but those are some of the core ones. Yeah.
So as you're saying, with the scalability, most people don't think of graph databases as supporting high ingest rates. They think of it more as recording relationships that are actually driving, either for analysis or understanding more in the metadata space than the data space in some cases. How you hinted at that sort of what do you actually think people are going to put graph databases in as operational databases in a broad way? Or do you think that they will still be more in the metadata relationship analysis side?
Yeah, I think certainly to begin with, the mainstream adoption is going to be driven by that, the relationship, driven applications. But certainly there are examples of companies that are adopting it for more, operational workloads. And it gives me an opportunity to highlight that at 5:05 today. I'll be moderating the adoption panel, and we've got some customers on there that are definitely using it for operational applications rather than just specific analytics. So I would encourage you to attend that. I won't speak for them, but they'll be explaining why they chose, obviously Neo4j specifically, but graph databases in general. Yeah.
Previous slide, I think you referenced unstructured data models, highly unstructured data models, highly unstructured data.
Right.
Just wanted to clarify my understanding of that. You're referring to like domain models where you have a lot of types where there's a lot of properties in that type of thing sparsely inferred.
Yeah, that's what I mean. I think I used the term, can't remember what I used now. It wasn't specifically unstructured. What was it? Multi-structured. So yeah, I mean, just taking the fact that it's not necessarily unstructured. I mean, all data has potentially a structure, but as you say, where you've got data sets where the structure may be quite sparse and missing aspects of that. Obviously, relational database being particularly bad at dealing with those kind of data sets, and obviously, we see graph database and also other NoSQL databases being more applicable to those kind of environments.
Do you think that the relational database is more space required to store all of the unused knowledge?
So okay.
Relational databases fall down because of the space required?
Well, I mean, it can be, depending on the nature. It's more to do with, we see that as actually the efficiency of processing the queries. Obviously, if you have a lot of null values, it can significantly impact the analysis and the queries that you perform. And actually, that goes back to the point, scalability, performance, relaxed consistency, etc. Performance can be an issue. Yes, you may be able to store a particular data set in a relational database. You may be able to work around some of the unstructured, semi-structured aspects of that to store it. But actually, when you come to query that and analyze it, it could be the performance of the analysis the way you fall down and may then look towards an alternative. Anyone else? Yep.
Have you considered subcategorizing the graph technology? I mean, you sort of did semantic part of
Yeah.
And in defining what are the categories of graphs and what are the useful for. Because I think there's a little bit of confusion as to, I wouldn't necessarily eliminate already semantic graphs. I could use certain stuff that takes into out there.
Yeah.
And the same with Neo4j as more of a property type graph.
Yeah.
And they're very different in terms of how people use them.
Exactly, yeah, and that's just, to be clear, we're not sort of saying the RDF semantic stuff is not interesting. It's just more with our view on the world. We're more interested in those being adopted for more kind of commercial enterprise projects where we don't necessarily see those being adopted for those right now. But there are going to be projects. There are going to be interesting projects. But yeah, I think the division of this sector is going to be something that we'll be looking to do more of, and I think it's something that, as you said, the graph database vendors are more interested to do because there is that potential for confusion. And I think it is one of those things, the more you dig down, the more kind of you get overlapping technologies and overlapping use cases, and so it is kind of complex. We've done that for the wider, I didn't have it in here, but we've done that for the wider database landscape, very much kind of divided up into different technologies and where they fit in different aspects. And that's given me a headache just doing that for the relational, structured, unstructured. So going down even deeper, it's definitely something we're interested in exploring. But I think as the technology matures and we see more adoption of that, it will become clearer where some of those technologies really fit and how we can divide that up. But yeah, it's definitely something we're interested in looking at, and I think will benefit the adoption of graph databases and understanding of graphs in the long run. Okay, any others?
So you hinted at the end users not necessarily knowing when they have a graphical problem.
Yeah.
That's something I'm working on. I work on a tool that deals with idea discovery and development and also work discovery within teams. And the core differentiator is that it's on this graph database. But when I'm talking to people about this functionality, I'm not really sure what words would resonate with them in terms of knowing if they have a graphical problem.
Right.
And so I'm wondering what sort of insights you have when you're talking to the end users.
Yeah, I mean, again, come to the panel later, but I think what we've seen is, it comes down to actually not necessarily talking about the technology itself and the model but about the benefits you will get from adopting that model in terms of, it could be developer flexibility and speed, it could be, higher performance in terms of the analysis. So yeah, I think that's where we've seen the companies be successful, where they focus more on the benefits they get from graph rather than trying to articulate the graph model itself, which obviously the higher up you go in an organization, the less that makes any sense whatsoever. So, but yeah, as I say, attend the panel later, because that's one of the things we'll be talking about with the end users there, and what they've done and how they, the benefits they've seen and the advice they can pass on. So yeah, it's 5:05 in here, I think. Yeah.
Okay, Matt, I'd like to thank you very much.
Thank you.